Matrix multiplication. So when we multiply a matrix, it's a little bit different than add and subtract. What I have here is an example of a 1 by 3 multiplied to a 3 by 1. So when we do that, as you can see in my example here, we're going to multiply these elements plus these, the product of those. This can only be done if the number of elements in the row of the first are the same number of elements in the column of the second. So that's just multiplying a row column matrix. The way we easily notice that is if we're multiplying a 1 by 3 and a 3 by 1, if these inner numbers match, then the product can take place. If not, then it cannot take place. And actually, these outside numbers also give us the dimensions of the product matrix. This one happens to be a 1 by 1. So when you do that process, multiply these two numbers plus the product of these plus the product of these, then this equals a -9, but technically the answer is the matrix -9, and it is a 1 by 1 matrix. So notice here that the inner, I call them the inner dimensions, must match before you can do the multiplication. Let's see. Moving on to the next page, I'll let you read that. So what we want to do is find the following products if possible. So let's get started. So what I'll do, since this is a 2 by 3 and this is a 3 by 2, notice the inner numbers are exactly the same, so that means the product can happen. And the outcome, the product, will be a 2 by 2 matrix. So I'll start here, and I'm going to multiply these elements just as I did on the previous page, and then I'll multiply here, and then I'll go down to row 2, multiply here, okay? Or it's a combination of add and multiply. So what I'll do is I'm going to start with -3 times -6 plus 4 times 2 plus 1 times 3. Then I'll stay with the top row here, and then I'll have -3 times 4. I'll have 4 times 3, and then I'll have 1 times -2. And every time we multiply those elements, they're always added to the previous, which is why I have addition here. Okay, so now I'll move to row 2. I'll have 5 -6, 5 times -6, and then I'll have plus 0 times 2, and then I'll have plus 4 times 3. Going back to the 5, I'll go 5 times 4 plus 0 times 3 plus 4 times -2. Let's close that matrix off. Now let's get our arithmetic. I've got 18 plus 8 plus 3. I've got -30 plus 0 plus 12. Let's see, that's 26, that's going to be 29, that's going to be -18, -12 plus 12 minus 2. This next element will be -2, and this is 20 plus 0 plus -8. That should give me a positive 12. So my product, my answer, is the matrix 29, -2, -18, and 12. Notice that it is a 2 by 2 as predicted. And we have our product matrix. Here I have a 2 by 3, 2 row 3 column. Here I have a 2 by 2. My inner values don't match, so no multiplication can happen here. It's impossible, okay? So looking down here at the bottom of my page, just a few properties to be aware of. We do have the associative property of matrix multiplication. As long as the dimensions work, then you can have associative property. We can also have the distributive property of matrices. Again, as long as the dimensions work, then you can have that property. So one thing to notice, multiplication is very specific in matrices. This A multiplier is on the left of the parentheses. That means it has to be on the left of the respective matrices in the sum or in the parentheses. Likewise here, where the A matrix is on the right, when I use the distributive property, then that A matrix must be on the right. So we can't mix those up. Matrix multiplication is not necessarily commutative. And we're going to see that here in just a minute. It's the wrong page. Okay, let me just put this one back. It's complete. I'll walk you through that one. Sorry. Here I'm going to multiply A times B. There's A times B. I've got 2 by 2's. So notice what I have down here. I have 1 times -2 plus 4 times -5. Do that math and you get your -22. Okay, stay with the row. Come here to the second column. 1 times 4 plus -4 times 3, right here. That adds together to -8. Move down to my next row. 3 times -2 plus 2 times 5. -6 plus 10 is 4. And then I have 3 times 4 plus 2 times 3, right here. And that's 12 plus 6, which is 18. So there is, again, my 2 by 2 matrix. So this is my answer. All right. The next thing we want to show you is B times A. This is just a demonstration to show you that you don't necessarily get the same thing when you switch order of product of matrices. So now we're going to do that. So we still have a 2 by 2 times a 2 by 2, which we can do the multiplication. So let's do this one. I've got -2 times 1 plus 4 times 3. -2 times -4 plus 4 times -2. 5 times 1 plus 3 times 3. 5 times -4 plus 3 times -2. Notice there's some nice little check thing right here. Everything in parentheses down this first column, 1, 1, 3, and 3, have to reflect those values. And then -4, -2 have to reflect those values. And I think I caught myself in an error here, and I think I've caught it soon enough. This should be a +2. Okay, so let me go back and fix those. That won't change this, but it will change this. And then this, and then this. Okay, so make sure you write your matrices down correctly. But again, just reflect that. And look at the -2 and the 5 and the 4 and the 3. And the -5, the 4, and the 3. All that positioning has to take place. So -2 plus 12 is 10. 5 plus 9 is 14. 8 plus 8 is 16. -20 plus 6 is -14. So that product, so this one is A times B. This one is B times A. Notice they're very different. Barring I make a mistake. I could have made a mistake. It does happen. You already saw me make one. So this is B times A. So that's why on the previous page you make very sure that if your matrix is on the left, it stays on the left. If it's on the right here, it stays on the right, because it will produce two vastly different answers. Okay, so that is multiplication of matrices.